If I take A equals to Moein, Ali, Hina, Rida, it is also a typical form of the list, which is the collection of the items. Moein, Ali, Hina, Rida are the collection of the items. These are the items, these are the elements of the list which are enclosed in closed brackets. They are strings. Last time we had integer, but don't forget you have to put quotes for the string. Moein inside the quotes, comma, Ali inside the quotes, comma, Hina inside the quotes, comma, Rida inside the quotes. So for the string you have to put the quotes, and then you need to enclose them in the closed brackets. So it is the typical form of the list in the Python, which has the collection of the items. Which items? The names of the classmates. These are the classmates. So I hope you got the idea and know that what is list, what we mean by the list, and how it looks like. List of list. Let's talk about the list of the list, which means that list within the list. List of list means that list within the list. Let me take an example. Example number 5. C equals to 1, 3, 6, Rihanna, A, B, hello. Check the print of C, you will get the same thing in the final output. Look, you can take the list within the list. Look, it is a list. From here up to here is main list. But you can take the sub list within the list. From here up to here is my one list. From here up to here is my second list. So we have used two sub lists, this one and this one, within the list. From here up to here is one element or one item, comma. From here up to here is my second element. For the outer list, I repeat it, for the outer list, from here up to here is one item or one element. From here up to here is my second item. This whole thing is my second item for the outer list. But when it comes to the within the list, these are the items, these three are the items, the collection of the numbers for this first list. And these are the items of the string, the collection of the strings for the second sublist. So again, it is not necessary that you must take only strings, or you have to take all the integers, or you have to take all the names. You can take the mixture of items. It is absolutely up to you. It doesn't affect the list as long as this whole stuff are enclosed inside the closed brackets. So when you call the identifier C by the print function, you will get this whole thing, this whole information in the output when you run the program. I'm going to tell you again that you can use the Colab, Jupyter, Visual Studio, or any other platform to run these programs. Personally, I'm using the Colab. So it is very easy to use the Colab as long as you have the internet access. Just simply type this expression and then take the print of C. You will get this thing in the output. Addition operator. Let's use the addition operator to make a list. Look, we already know about the arithmetic operators. We understand, we have learned the arithmetic operators, that what is addition operator, what is multiplication operator, what is exponentiation operator. We understand, we have learned all the arithmetic operators before. So let me use the addition operator here to make a list. Example number 7. If I have print of 1, 3, 5 plus 7, I will get 1, 3, 5, 7. Look, I have two lists. One is here and the second one is here. I added this list to the first one. When you add 7 within the list to the first list, you will get the fourth items here in a single list. I repeat it, I simply added two lists together, this list to this one, by using simple addition operator. It is a simple addition operator. When you do so, by taking the print function, in the output you will get 1, 3, 5, 7, which means that I have added one extra element to this list. So now I have 4 elements. Total I have 4 elements, 1, 2, 3, 4. Now all the elements came inside a single list in the output by using addition operator. When you add two lists together, that's how we can simply make a single list by using the addition operator. I'm telling you again and again that it is a simple procedure, a simple way how to make a list in the Python. Nothing more than this. Just simply learn that when you add two lists together, what you get in the output. Look, you can give the name A to this information, and then when you take the print of A, you will get the same thing. Whether you use the print function directly, as we did here, print of list1 plus list2, or you can give the name A or B or C or X or Y, whatever name you want, you can give it. You simply give the variable name or identifier to this information, addition of these two lists, and then when you call the variable A, by taking the print of A, you will get the same thing, 1, 3, 5, 7. So whether you use directly print function or use the variable name, ultimately you will get the same answer. Example number 8. Print of 2, 4, 6 plus 8, 10.5. When you run the program, you will get 2, 4, 6, 8, 10.5. Again, I have the addition of two lists. From here up to here is my one list. This is my second list. In the second list, my second number is in the float form. So you can take the combination of the numbers. It can be all integers, all float numbers, or the combination of integers and float numbers, even numbers, odd numbers, whatever you want, you can make the collection. Now when you take the print function, run the program in the Colab, you will get all the 6 elements, in a single list, We added this list to the second list by using the addition operator here, So you will get all the 5 elements together in a single list here by using a simple addition operator. When you add first list to the second list, it will bring all the 5 elements together in a single list. That's how we can add two lists together to make a single list in the final output. Example number 14. If I have print of y in sky, stars, z, run it, you will get false. Look, again I used belongs to operator, which is in. Y does not exist here. Look, we have y here, but it is with the sky. Sky is something different. Sky is a single element. Stars is another single element. Z is the third single element. We don't have any y single element here. I repeat it, we are not talking about a single character here. Yes, character y exists here with the sky. We are not talking about it. We are talking about the element. Like we have z here. If we have y here instead of z, then you will get true. But since we don't have y here as a single element, therefore when you run it, you will get false. Y does not exist among all these 3 elements. We have only 3 elements, sky, stars, and z. There is no y element. Therefore, it returns false in the final output. You can do the same thing as we did in the previous example. Instead of directly put the print function, you can also give the variable name and then take the print of variable name, or you can simply type this expression in the Colab, run it, you will get the same answer. It is absolutely up to you. There are 3 ways that you can make the list here using the belongs to operator. Greater than operator. Let's talk about the greater than operator. Greater than operator is also the comparison operator. Example number 16. Print of 2, 4, 7 is greater than 1, 2, 3. When you run it, you will get true. Look, we have used the comparison operator, which is greater than operator. Can we see that this list on the left side is greater than the list on the right side? Yes, absolutely, it is true. Because look, the first element of this list is 2. And the first element of this list is 1. So 2 is greater than 1. The second element of this list is 4. And the second element of this list is 2. Again, 4 is greater than 2. Similarly, 7 is greater than 3. So all the elements of list on the left sides are greater than all the elements of the list on the right side. Therefore, it returns true. It returns true because it is pretty much true. This is the first way of the solution. The second way is you give the variable name x equals to 2, 4, 7 is greater than 1, 2, 3. Take the print of variable x, you will get true in the final output. Let me check the third way of the solution, which is directly put 2, 4, 7 greater than 1, 2, 3. Just simply put this expression in the Colab. When you run the program, you will get exactly the same answer true. So it is absolutely up to you whether you use the print function, whether you use the variable name, or whether you type this simple expression in the Colab. We have done with the minimum value of the list. Now we are going to solve an example where we will check that how to get the maximum value of the list. Example number 18. If I have printf maximum of 1, 4, 7, run it, it returns 7, which is the maximum value of the list. It is exactly the same thing, just put max instead of mean. Max means maximum. Use the maximum function, maximum of 1, 4, 7. What is the maximum value? We have only 3 elements here, 3 values here, 1, 4, 7. 7 is the biggest value. It is the maximum number among all these 3 elements. Therefore, when you run this program, it will return 7, which is the maximum value. That's how we can identify the maximum value in the list by using the maximum function. This is the first way of the solution. The second way of the solution is to directly put maximum of 1, 4, 7, run it, you will get the same answer 7. We are doing it without the print function. The third method is to give the identifier. Name it by the x equals to 1, 4, 7. Call the variable x with the maximum function. Again, you will get 7, which is the same answer we got in the last 2 methods. So there are 3 ways that you can solve these programs. Indexing of the list. We already know that what is indexing. We had a complete section about the indexing. We are very much familiar with the indexing at this stage, that what is indexing. But let me repeat it again. In computer memory, the information has specific value, specific tag, specific label. That specific value is what we call the index value. For example, if we have any integer or any string or any other piece of information in the computer memory, it has a specific address value. That address value is the index value. We also know that index always starts from the 0, 1, 2, 3 up to positive infinity when it comes to the positive indexing. In negative indexing, we start from -1, not from 0. -1, -2 up to negative infinity. The process where we play with the index of the information is called the indexing. That process, that phenomena is called the indexing. So let's first talk about the positive indexing. We are going to do the positive indexing first. We will do some examples how to find the positive indexing of the list. Example number 1. If I have a equals to 1, 3, 6, 11, take the print of a of 2, it returns 6. Look, it is a list. It is a list where the items or the elements are the integer. There are numbers. There are numbers in this list. It is the collection of the numbers, positive numbers. So this whole information has been saved with the name a, which is variable or identifier or a placeholder in the computer memory. So to access this information, we need to call a. It is the label, it is the mark where we need to call it to access this kind of information in the memory. Therefore, I need to call a, print of a of 2 inside the closed brackets. So when you take a of 2, what is 2? 2 is that specific index address. That specific address in the computer memory. It is the index value. We already know that indexing, positive indexing starts from 0. 0, 1, 2, 3. So the index value in the memory for 1 is 0, the index value for 3 is 1, and the index value for 6 is 2. So at 2 index value, we have 6. Therefore, when you run this program, it will return 6 because 6 has index value 2 in the computer memory. This is the method, this is the way to find the index of a list. Print of a of 2 inside the closed bracket. Don't forget this closed bracket. I repeat it, it is the index value. When you put 2, it will return 6 because the index value for the 6 is 2. The index value for 11 is 3. When you put 0, you will get 1 here. So this is the one way to find the index of the list. Let me check the second method, which you can directly put print of 1, 3, 6, 11 of 2, which will also return the same value 6. It's just a slightly different way to get the same answer. This time I took directly the print function, print of 1, 3, 6, 11, and then of 2. What is 2? 2 is the index value. This is the list, from here up to here is the list, and this is the index value. So when you run this program, when you run it in the collab, you will get the same 6 in the output. Because remember, the index value in the computer memory for the 6 for this information is 2. I repeat, indexing starts from 0. 0, 1, 2, 3. So 2 is the index value for the 6, therefore it returns 6. This is the second way to find the indexing. Let me check the third way. We have a third way as well, where you have to put directly the expression here, which will return the same answer, 6. This time we don't have any print function, we don't have any variable name. We directly put this expression in the collab, the list, and then of 2 index. When you run it, you will get the same answer, 6. The index, at index 2 we have element 6, therefore it returns 6. So these are 3 different ways to find the indexing. Example number 2. A equals to 1, 3, 6, 11. Take the print of a of 0, it returns 1. Look, this time I took the index value 0. At 0 we have element 1. 0, 1, 2, 3. Indexing starts from 0. So at 0 we have 1, therefore it returns 1 here. Print of a of 0. In second method, directly put the print function, print of 1, 3, 6, 11 of 0. It returns the same 1. Similarly, let me check the third method, which is the direct method, without using any print function or without using any identifier. When you run it, you will get the same answer, 1. Because look, at 0 indexing is the address in computer memory which holds this information, 1. Index value of 1 is 0, index value of 3 is 1, index value of 6 is 2, index value of 11 is 3. So at 0 index value it returns 1. Example number 3. If I have a equals to 1, 3, 6, 11, but this time when I have print of a of 1, it returns 3. I plug in the index value 1 here, a of 1. Which elements has index value 1? 0, 1. At 3 is the element, 3 is the item of this list which has index value 1 in the computer memory. Therefore, it returns 3 in the final output. But what about the second method? According to the second method, directly take the print of 1, 3, 6, 11 of 1, which returns the same answer, 3. Just directly pick the print function. And also, what about the third method? According to the third method, we have the same answer, 3. Example number 11. A equals to 2, 5, 3, 9, 12, 30. This time I have print of a of colon 0, which returns empty list. Look at here. If you skip the 0 on the left side, by default the program will run from the 0 indexing value, even if you don't have any value on the left of the colons. So it's pretty clear that we are gonna start from the 0 here. But when it comes to the right side, we have 0. We have 0 indexing. We have 0 indexing. What is the value of this list and 0 index value? 2. 2 is the value. 2 is the value at index 0. At index 0 in the memory. But why we got empty list? Because remember, on the right of the colons, whatever value you have, the last value is not counted. The last indexing value is excluded. You have to go before the last value. For example, if you have 0 indexing, which means that 0 is not included. 0 is not included, therefore we don't have 2 here. We have empty set. If you have 1 here, then 1 is not included. Just before 1, everything is included, but 1 is not included. So you will get 2 here. If you have 3 here, then the value at 3 index value is not included. The rest of the values are included, like 0, 1, 2. So you will have 2, 5, 3 here. If you have 3 index value, because at index value 3 we have 9. 9 is not included. Before the 3, Everything is included, but 3 is not included. So the last value on the right of the colons is not included. That's why we have empty set. 2 is not included. 2 is at 0 indexing, which is the last value. It is not included. Before 0, we don't have any value. 2 is the first value. So before 2, we don't have any value here. Therefore, it returns empty set. This is the first way to find the indexing. You can also go for the second method and also for the third method. It is up to you. Up to this stage, I hope you understand that how to do the first method, how to do the second method, and how to do the third method. I'm not going to repeat this again and again. I'm going to take only method 1. You can go for method 2 and for method 3 as well. It is up to you. If you go for method 2 and for method 3, you will get the same empty set. There will be the same output for all the methods. Example number 14. Clubs equals to Barcelona, Real Madrid, Chelsea, Manchester United, PSG, Juventus. When you take the print of clubs of colon and 0, it returns empty set in the output. Look at here, if you have nothing, if you don't have any number on the left of the colon, it means that the program will start by default from the first element, up to the 0 index. What is my 0 index? 0 index is the Barcelona. At 0 index, we have Barcelona. Because remember, index, positive indexing starts from 0. 0, 1, 2, 3, 4, 5. So at 0 index value, we have Barcelona. But it is the last value on the right side. We already know that if we have the value on the right of the colons, this value will not be included. Before this value, everything will be included. But exactly that value will not be included in the final answer. Since the exact index value here is 0. So at 0 we have Barcelona, which is not included. It is the end value. Do we have any other element before Barcelona? No, we don't have any element before the Barcelona. It is the very first element. Since we have no element before the Barcelona, therefore it returns empty set. If we have clubs of colons and 0. You try the second method and the third method, you will get the same empty set. Example number 32. A equals to 2, 5, 3, 9, 12, 30. When I run it, I will get empty list. Look, on the left of the colons, we have index 2. So at index 2, we have 0, 1, 2. Exactly at index 2, we have 3 here. So the program will start right from here, from 3. Up to the index 2, but index 2 is not included. Remember, we have index 2 on the left of the colons, and also we have index 2 on the right of the colon. 2 is included on the left of the colons, but 2 on the right side is not included. Just before 2, all the values are included, but 2 is not included. So exactly at 2, we have 3 here. As we know that the program starts right from 3 up to 3, but 3 is not included, which means that you will get empty set. So make sure if you have the same value on both sides of the colons, you will get empty list. If there is 1, 1, you will get empty list. If there is 5, 5, you will get empty list. Since we have 2, 2 here, both the index values are same on both sides of the colons. Therefore, I got empty list here. We got empty list. Example number 1. X equals to 0, 1, 2, 3. X dot append of 4. Check the print of X. You will get 0, 1, 2, 3, 4. Look at here. From here up to here, this list has been named with a variable which is X. X is the variable name, it is the identifier, it is a placeholder which holds this information from here up to here. It is a list with the elements 0, 1, 2, 3. Now, I want to append 4. I want to add one more element to this list. So what I'm going to do, I'm going to use the append function, x.append of 4. Whatever value you want to put it there, you just plug in here. If you want to put 4, 4 will be added. If you want to put 5, 5 will be added. If you want to put 6, 6 will be added. Then check the print of X. Call the X variable with the print function. The final output will be printed here with an extra element which is 4. So before we had only 0, 1, 2, 3 elements. By using the append function, we added an extra element 4 there. Therefore, we got an extra element in the output now. So we have 0, 1, 2, 3, 4. We have total 5 elements now in the output because we added an extra element with the help of the append method. Example number 4. List 1 equals to 0, 1, 2, 3. List 2 equals to 4, 5, 6. List 1 dot append of list 2. Take the print of list 1, you will get 0, 1, 2, 3, 4, 5, 6. Look, this time I have two variables, list 1 and list 2. So we have two expressions. For the list 1, we have 0, 1, 2, 3, this list. List 1, this variable, this identifier, keeps this information in the memory. This identifier, which is list 2, this is the second variable name, keeps this information, which is the list of 4, 5, 6 elements. Now I wanna append list 1, list 2. So just write list 1 dot append of list 2. It means that add list 2 to the list 1. Here list 2 considers a new element for the list 1. So when you take the print of list 1, look, list 1 is my this list, 0, 1, 2, 3. When you take the print of list 1, you will get 0, 1, 2, 3, and then comma this second list, list 2, 4, 5, 6. Because we have appended list 1, which is this, with the list 2, which is this. Therefore, you will get extra part here, which is this list, when you append list 1 by the list 2. Example number 10. X equals to 0, 1, 2, 3. X dot reverse function. Take the print of x, you will get 3, 2, 1, 0. Look at here. I give the name x to this list. Then I use the reverse function here, x.reverse. You just write x.reverse and the two parentheses. This is the reverse function. Don't write anything inside the parentheses because it is not something to add or insert or append any element to the list. If you remember last time in the insert method and in append method, we were appending or inserting any element to the list. That's why whatever thing we were adding to the list, we were writing it inside the parentheses. But since it is just a simple reverse function, therefore you don't need to write anything inside the parentheses. Just type x.reverse and the two parentheses. When you call the x variable, the x identifier, take the print of x, run the program, you will get everything in reverse order. Look at here, we have 0, 1, 2, 3. But in the output, we got 3, 2, 1, 0. So all the elements of the given lists are in reverse form, in reverse order in the last output. By using the reverse function, that's what the reverse method does. It just changes all the elements in reverse order. Example number 16. X equals to 0, 1, 2, 3. X.pop function. Take the print of x, you will get 0, 1, 2. Look at here, the given list is x equals to 0, 1, 2, 3. This list has been named with the identifier x. Now take the pop function, x.pop of parentheses. Don't put anything inside the parentheses, simply put two parentheses in front of the pop and then take the print of x. What is x? X is actually this variable, the identifier. So when you run the program, you will get this list where 3 has been removed here. Look, in the list we have only 0, 1, 2. The last element, which is the 3, has been removed as we use the pop function. So there is no more 3 in the output. In the output you will get only the first 3 elements where the last element has been removed. So that's what pop function does. Example number 17. X equals to 5, hello, a, true. X.pop function. Take the print of x, you will get the output 5, hello, a. Look at here, we have total 4 elements, 5, hello, a, and true. These are the 4 elements in the given function. So this whole information has been saved with the name with the identifier x. Now take the pop function for the x.pop function. Now take the print of x, call x with the help of the print function. When you run the program, you will get 5, hello, a, where the last element, which is true, has been removed. This true has been removed from the list, from the given list. We left only with the 3 elements 5, hello, a in the final output. Example number 22. Names equals to Moein, Nia, Jerry, Lisa. Names.clear function. Take the print of names, you will get empty set. Look, this time I took the strings. I took the list of the strings. And then when I used the clear function names.clear, then take print of names, therefore I got only empty set in the final output when you take the print of names. So whether you take numbers or the strings, clear function does the same job. It clears all the elements of the given list and will always returns the empty set. Example number 26. X equals to 0, 1, 2, 3. Print of x.count of 0, which returns 1. Look, I took the list with the elements 0, 1, 2, 3. Now I need to use the count function. This is the count function. To use the count function, I'm going to call print function. Print of x.count of 0. So I want to know that how many times the 0 have been used. Now I'm going to use the count function here. To use the count function, I need to put print of x.count of 0, which means that how many 0 I have in the given list. When you run it, you will get only 1, because we have only 1 0 in the list. But if we have 0 here and 0 here, then it will return 2. Since we have only 1 0, therefore it only returns 1. I repeat it. It is not something to count all the elements. We have total 4 elements. It is not for the total count. It is only for the elements, for the specific elements, that how many elements have been used in the list. You have to specifically put it inside the parentheses. Don't forget, you have to put, if you want to check that how many times we have 3 in the given list, you have to put 3 inside the parentheses. So specifically you have to mention that elements inside the parentheses. That's what count method does, and that's how count function works to check that how many total similar elements we have in the list. Example number 27. X equals to 0, 1, 2, 3, 3. Print of x.count of 3, which returns 2. Look, this time I have 3 here and 3 here, so there are total 2 elements of 3. When you take the print of x.count of 3, you will get 2, because as I told you, it counts the total number of similar elements. What are the total number of 3 here? We have 2, 1 and 2, therefore it returns 2. If you have only 1 3, it returns 1. If you have 5 3, 5 times 3 in the given list, it returns 5 here. So it specifically counts the number of that specific elements which you mention inside the parentheses, not the count of total elements. Understand the difference. I hope you got the difference now. Fusion of methods. What is fusion of method? Fusion of method is the combination, is the mixture of more than one methods. There can be 2 methods, there can be 3 methods. So according to the fusion of methods, here we take a fusion of 2 or more than 2 methods in a single program. As I told you, it is pretty clear from its name, fusion of methods, the combination of 1 or more methods. Therefore, we take a fusion of 2 or more than 2 methods in a single program. Let's check the examples. Example number 31. X equals to 3, 1, 0, 2. X.sort function and then x.reverse function. When you take the print of x, you will get everything in reverse form, 3, 2, 1, 0. You will get this output. Look at here, we have used 2 methods, sort method and reverse method. So it is the fusion of sort method and reverse method. We have used sort function and reverse function. Look, the given list is x equals to 3, 1, 0, 2. When we use the sort function x.sort, what sort function does, put all the elements in ascending order, in proper ascending order. Look at here, in the given list, the things or the items are not in the proper ascending order. We have 3 and then 1 and then 0 and then 2. Everything will be in a proper ascending order. But at the same time, in the third step, you have to take the reverse function x.reverse. It will reverse everything in the opposite direction. Look, with the help of the sort function, we will have 0, 1, 2, 3. But when you take its reverse, you will get 3, 2, 1, 0 in the reverse form. So first, put all the elements in proper ascending order 0, 1, 2, 3, and then the reverse function, take the reverse of all these elements to have 3, 2, 1, 0 in the final output. So it is a fusion of two methods, sort method, reverse method. This is the typical example for the two-dimensional list. Look at here, x is the variable which equals to this expression. Our main list is here, from here up to here. This is my main list. Now the element of this list is a list by itself. Look at here. From here up to here is one list, from here up to here is another list, from here up to here is a third list. But for the main list, it considers a single element or a single item. This is my second single item. This is my third single item for the outer list, for the main list, for this list. So this whole information have been saved with the name x, which is identifier, a variable, or a placeholder in the computer memory. Whenever you want to access this information, you need to call to the x. It is the identifier, it is the identification, it is the tag, it is a label for this whole expression. So that is the reason we call it the two-dimensional list. Two-dimensional list. Because remember, all the elements of the lists are the lists. So which means that we have list within the list. Therefore we call it 2D, two-dimensional list. If you remember, last time we had only numbers or any strings, but this time each item and each element of the list is a list. So we have lists within the list, and that is the reason we call it two-dimensional list. I hope you got the point now. Mutability of the two-dimensional list. In this session we are going to talk about the mutability of the two-dimensional list. How the two-dimensional list is mutable. How we can do changes. From mutability we mean changes. Change the item or replace the item by another item. Or change the sub-item by another sub-item. This is what we call the mutability of the list. The changes of the list is what we call the mutability of the list. Let's do some examples here. Example number 9. X equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. X of 0 index of 2 index equals to 12. Take the print of x of 0 of 2, you will get 12 in the output. Look, my given two-dimensional list is this, which has been identified with the identifier x, or with the variable x. It is a placeholder which keeps this whole information from here up to here in the computer memory. So to access this information, we are going to call to this tag, to this identifier, to this variable. It is the label, it is the tag of information for this whole two-dimensional list. But I want to do some changes here. How to do changes? If I take x of 0 index, we already know that the very first index number is for this or all element, for this whole element, or for this whole element, or for this one. So at 0 index, exactly at 0 index value, we have the very first element, which is from here up to here. It is the very first element. At the second index number, which is 2, we have this 3. We have this 3, like 0, 1, 2. 0, 1, 2. So at index 2, we have this 3. But now, if I make this equals to any value, it can be any number. This value, this number, this value, which is at index 2, will be replaced by this new value, So we are going to replace 3 by 12 now. If you put 12 here, it will be replaced by 12. If you put 10 here, it will be replaced by 10. So when I take the print of x of 0 of 2, I will get 12 in the output, because remember, now this 3 is no more 3 here. We already replaced this 3 at index 2 by the 12. So for the 3, my new number will be 12. Therefore, when I take the print of x of 0 of 2 at index 2 here, I will have 12 now. Therefore, it returns 12 because I have changed it here. That's what we call it mutability. Mutability of the two-dimensional list. To change something here. This process, this phenomena is what we call mutability of the two-dimensional list. I repeat it again. The very first index number is for this or all element from here up to here. The second index number is for this individual sub-item inside this list, which are 1, 2, and 3. Now exactly at 0 index, we have this very first item from here up to here. Exactly at index 2, we have this third sub-item 0, 1, 2. So at this two index we have 3. Now if I make it equals to 12, it means that this 3 is no more 3 here. It will be replaced by the 12 because we have changed it here with the help of this expression. We have changed it here by 12. If you put 5 here, it will be replaced by 5. So since we have 12, therefore it is no more 3 here. It is 12. When you take the print of x of 0 of 2, you will get in the output 12 instead of 3. 12. Because this 3 has been replaced here by 12 now. So you will get 12 in the final output. Example number 10. X equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. This time let me take x of 1 of 0 equals to 2. Take the print of x of 1 of 0. You will get 2 in the output. Look at index 1. Exactly at index 1 we have this item. As I told you, the first index number represents the item in or all from here up to here, like 0, 1, 2. So at index 1 we have this item from here up to here, which is actually a sublist. Through the second index number we are going to access the sub-item inside this list, like 4, 5, 6. So at 0 index value we have this 4. If you make it equals to 2, it means that you have replaced this 4 by 2. Now we don't have 4 anymore. We have 2 instead of 4 here. Then take the print of x of 1 of 0, you will get 2 in the output. Because remember, at index 1, which is this item, at index 0, which is 4, we have 2 now in the output. Because it has been replaced by the 2, by these 2. So you will get 2 in the output. If you put 5 here, you will get 5. If you put 15 here, you will get 15 in the output. It is up to you. You will get the new value, not this old value in the output. Example number 11. Let me take again the same two-dimensional list with the 3 elements. Take the print of x of 1 of 0, which will return 5 in the output. Look at index 1. At index 1, which is my this element, the first index value stands for this or all item from here up to here. From here up to here. So at index 1, which is index 0, 1, 2. So at index 1 we have this item, this element from here up to here. At second index number, we can access the sub item here of this list. So at index 0 we have this 4. Now if I make it equals to 5, it means that I have replaced this 4 by the 5. Now my new number will be 5, not 4, because it has been replaced by 5. When you take the print of x of 1 of 0, you will get 5 in the output. Look, this is the first way of the process. With the help of the second way, you can skip this print function. You can simply put x of 1 of 0 in the separate cells. You will get exactly the same 5 output. You can skip this print function. Just simply type x of 1 of 0 in a separate cell in the Colab or Jupyter. Run it, you will get exactly the same 5. Example number 12. X equals to 1, 2, 3, 4, 5, 6, 7, 8, 9. Let me take x of 2 index of 2 equals to 13. When you take the print of x of 2, you will get 13. Look, this time my first index number is 2, which is for this or all item from here up to here, or from here up to here, or from here up to here. At index 2 I have this whole item from here up to here. At the second index number, which is also 2, I have this 9. This second index number is for this sub-individual item inside the list, like 7, 8, 9. So at index 2 I have 9 here, because remember indexing starts from the 0. So I have 0, 1 and 2. At index 2 I have this 9. Now when you make it equals to 13, which means that this 9 has been replaced by 13. There is no more 9. You are going to get the new value, which is 13 here for the 9. Therefore, when you take the print of x of 2 now, you will get 13 in the output instead of 9, because it has been replaced by 13. Your new value will be printed in the final output. So we did mutability to the given two-dimensional list with the help of this expression. In the second method, you can skip this print function, remove this parenthesis, and simply type x of 2 in the separate cell in the Colab or in the Jupyter, run it. You will get exactly the same 13 answer in the output. Example number 13. Let me take again the same two-dimensional list, but this time I will take x of 0 equals to 10, 12, 15. When you take the print of x of 0, you will get 10, 12, 15. Look, this time I took x of 0 index. As I told you that the very first index number is for this complete item from here up to here, or from here up to here, from here up to here. The first index number is not the representation for the sub-individual item, which are 1, 2, 3, 4, 5, 6, 7, 8, 9. It is for this whole element, for this whole item. So at index 0, we have this very first item from here up to here, which is a sublist. Now, if I make it equals to 10, 12, 15, it means that this whole item, this whole list has been replaced by a new list with the elements, with the sub-items 10, 12, 15. Therefore, when you take the print of x of 0 index, you will get this new list with the 10, 12, 15 sub-items. This new list will be printed in the output. There is no more this list. It has been replaced. It has been changed by the new list, which is 10, 12, 15. Look, in the previous examples, we were putting the second index number here, like x of 0 or x of 0 of 2. So the second index number means to access the sub-item, the sub-element inside this list. But if you take only one index number, the first index number, which means that we are referring this whole item from here up to here, not the sub-individual item. Therefore, x of 0 equals to this list means that at 0 index number, which is this complete item, it will be replaced by this new list. Therefore, when you take the print of x of 0, you will get this new list, not this old previous list, this new list, because it has been replaced, it has been changed by this new list. Example number 14. Let me take again the same two-dimensional list, but this time I will take x of 1 equals to 1, 2, 3. Take the print of x of 1, you will get 1, 2, 3 in the output. Look at here, at index 1, I have this item from here up to here. As I told you, the very first index number is the representation for this complete item from here up to here, not for the individual item. For the individual item, we put the second index number here. But since we are taking only the first index number, therefore I'm referring this whole thing from here up to here. It lies at index 1, index 0, index 1, index 2. So at 1 we have this whole thing, because remember it considers a single item or a single element for this two-dimensional list, for this outer list. Therefore, index 1 returns this whole thing, not this individual item, this whole thing. So when you take the x of 1 and then make it equals to 1, 2, 3, when you take the print of x of 1, run it, you will get the new list 1, 2, 3. We know that at x of 1, we have this list. My previous list was with the sub-items of 4, 5, 6. But then what I did, I have replaced this whole item by a new list, by a new item with the sub-items 1, 2, 3. So this new list will be printed. This new item, this new element will be printed in the final output. Not this old one, this new one in the final output. Look, this is the first way of the solution. In the second way, you can skip this print function and simply type x of 1 in a separate cell in the Colab or in the Jupyter. Run it, you will get the same answer. That's how we can do changes to the two-dimensional list. We can change this complete item by another item, or we can change a single sub-item by another single sub-item. This whole phenomena is what we call mutability of the two-dimensional list. That's what we mean by the mutability of the list. So I hope you got the idea by now that how to do mutability to the two-dimensional list.